Good morning. I hope that you have enjoyed your holidays. There is only one small part which is left from this long chapter, trigonometry. I will cover this today. Might be you have also time to practice yourself. And then from next time, we start the next chapter. Okay. If you remember, we talked about the graphs of the sine function and cosine function, and we didn't talk about the graph of the tangent function. In the tangent function, we have a little bit of problem. So what is the main difference between sine and cosine and tangent functions? Let us check it from mathematical point of view. So let us say that the function f is the sine function, the function g is the cosine function, and the function h is the tangent function that we want to discuss today. And you see what is the big difference between the function sine and cosine and the tangent from a mathematical perspective? Yes?
The tangent function has a period of 180 degrees instead of...
Yeah, that's a good difference. Yes. If you remember, the period of these two functions were both equal to 360 degrees or 2 pi, but we also learned that the period of tangent function is just 180. Why was that? You remember long back when we were talking about the formulas for complementary and supplementary angles using the unit circle argument and symmetry, we learned that if I add 180 to theta, the tangent remains the same. Okay, so if I want to review this, for example, if you have this unit circle, if this angle is theta, if the coordinates are x and y, if I add 180 to this angle, I will end up exactly at the opposite point, yes? So if I add 180 to my previous angle, then my new angle will be from here up to here, which is theta plus 180 on the one hand. On the other hand, the end point will be exactly the opposite point. Yes? So now if I ask you what are the coordinates of this point, you will tell me, of course, I don't know x and y, but whatever they are, these two numbers are opposite of those numbers. So they are minus x and minus y. And if I ask you what is tangent of theta, if you haven't forgotten, tangent of theta is the y coordinate divided by x coordinate. And if I ask you what is the tangent of 180 plus theta, you will tell me again the ratio of the y coordinate over the x coordinate. But because both of them contain a negative sign, I will go back to the same point as yx. So it doesn't matter if I talk about tangent of theta or if I talk about tangent of theta plus 180 degrees, they are exactly the same. So this means that the period of tangent is a smaller, because when I talk about period, of course, it doesn't mean 360 doesn't work. Of course, if I add 360 degrees, I will go back to the same point and definitely it work. But you remember this, when people talk about the period, they are talking about the smallest possible number which is working, yes? So if I ask you, what is the period of tangent, you shouldn't say 360 degrees, even though technically 360 degrees also works. You need to tell me the smallest possible number that works. In this case is 180 degrees. So the period of tangent is, that's one difference. But that was not my goal. It is good that you told me this. So I was able to review this a little bit. But there's also another big difference between sine, for example, and tangent. Have you heard about the function that are continuous? Yes, a function is continuous if its graph can be drawn with one pen stroke. So the graph of the sine function, in principle, I can put my whiteboard pen on the whiteboard and try to draw it, and I don't need to lift it up and put it somewhere else, okay? So that means the graph is continuous. So this is the graph of sine function. I can draw it with one pen stroke. But if the graph of a function, for example, if I have 1 over x, we will discuss about these type of functions later in this course. but this is not that hard. If you ask GeoGebra to draw the graph of this function, you will see that the graph is not one piece. Okay, it is two pieces. One will be this branch, and the other will be this branch. So if this doesn't mean that there are two graphs for two functions. That is the single function that if you draw it using GeoGebra, you get two branches. These two branches together is the graph of what's this single function. And then you can see that this graph, these curved ones, this is the x-axis and this is the y-axis, they are not actually, this is not possible that I can draw them with one pen stroke, yes? I can draw this piece with one pen stroke, but if I want to go here, I have to lift up my pen and put it somewhere else and draw it again. So this means that this function is not continuous. And why do you think this happens, this odd behavior happens? And you can see where it is happening. Where is it happening? If you look at the x-axis, this breaking is occurring at which point?
X equals 0.
0. And why 0? You can see, you can feel that because the denominator includes 0 and I am not able to put 0. So I can put any number, any negative number for x, okay, but I'm not allowed to put 0. So I can get closer and closer and closer to 0 and calculate this. For example, let me start with the positive numbers. For example, I can put 1 over 100. 1 over 100 is a small number, very close to 0. Am I allowed to put 1 over 100 here? Yes, because if I take x out and put 1 over 100, the answer becomes 100. So it means that it is possible. Can I make it smaller? Can I get closer to 0 and still calculate this function? Yes. For example, if I put 1 over 1000, I am getting much closer to 0. But this still, I don't have still any problems, yes? Because if I take x out and put this number there, the answer will be 1000. The problem happens when I want to put 0 exactly, which is not possible, okay? And something like this happens for tangent, yes? This kind of behavior usually happens for all fraction functions. Because if the denominator of the fraction becomes 0, the function becomes undefined. Okay? So if I ask you what is the domain of the function f, it means what is the meaning of the domain of a function? It means the collection of all possible values that you can replace for x. Do I have any limitation for sine x? The answer is no. You can choose x whatever you want to, from minus infinity to plus infinity, and put it here and get an answer. Okay? So the domain of this function is the set of all real numbers. The domain of the function cosine is also the same thing. I do not have limitations for which values I can choose and put there. But for tangent, I have limitations, yes? Because even though tangent is apparently not a fraction, but you learned before that tangent x is just simply sine x over cosine x. So tangent is also a fraction in a disguised form, yes? So tangent x is equal to sine x over cosine x. So it is clear that tangent x is not defined everywhere. Do you remember one of the angles that tangent, we had it in the table. There were two angles on the table that we completed in the very beginning of this lesson. The tangent was not defined. You remember where? Because tangent is, what is tangent? Tangent is y coordinate over x coordinate. So if the x coordinate is 0, I have problems. Tangent is not defined. So where x coordinate is 0? X coordinate is 0. If I am on the unit circle, x coordinate is 0 either at this point, which means my angle is 90, or at this point, which means the angle is 270, or if you want to, minus 90. Okay? So there were two angles that you already know that the tangent is not defined. But that is not the whole story, because there are other numbers that cosine x is 0 and tangent is not defined. So let us write an example here to understand this. So example, determine the domain of the following functions. Okay. So I don't know if you remember this domain from Math 2C. So what is the domain of the function? So every function, let me also give you this picture. Every function is like a machine that takes input from you and gives you output. If you want to have a good diagram of a function, you can say that a function is a box, is a machine. So let me call it function f. I send an input there. This machine, depending on which type of machine this is, it will do some processing on my input and give something back to me. Okay? Using this diagram, you can have a better understanding of a function. So usually it is common that the input is represented by variable x. But it doesn't matter, you choose x, whatever you want, you could just, it means this is the input. Okay? And this machine do some process on this input and gives you something back. What is given back is called f of x. Okay, so be careful. Sometimes people say the function f of x, which is wrong. F of x is the output. The machine is something else. Okay, f of x is the product of the machine. Okay, so the machine, the box that you see here is the function itself. For example, I can say, when people say the function f of x equals to x squared, what does this mean? If you want, this is the simple way of writing this. This means that I have a machine, f. Whatever I send in, let me call it x, this machine square this input and gives it back to me. Okay? So when you see this, you need to imagine something like this. Okay, so this is an operator. So I send x inside it, f acts on it. So this is called, if you want to give it a name, what is this machine called, for example? Can you find a name, good name for this machine? This machine, we can call it the squaring machine. So whatever you send in, it squares it and gives you back. Of course, whatever is exaggeration. I cannot send, for example, bolts and screws in there, yes? So this means there are some limitations in the inputs that I can put in any function, in any machine. The collection of all possible inputs appropriate for that machine is called the domain of that machine, or the domain of the function. Is that clear? For example, do you think for a squaring machine, I have any limitations? For example, can I send a screwdriver there? No, because a screwdriver to power 2 is not defined. Okay, but can I, so what type of things I can send in? Yes?
Real numbers.
I can send every real number. It should be a number. For example, I don't know. So you can have meat grinder. Okay, that's also a machine. You put meat there and then you get minced meat out. Okay, so there I cannot send numbers. Okay, so the input, the domain of that machine is what? Yeah, might be all kinds of meats, okay? But the output is the minced meat. There I cannot send any numbers there, yes? We cannot say square root of 2, send it to the mincing machine, okay? So here, the collection of all possible inputs of any machine or a function means its domain. That's the domain of the function. And the collection of all outputs that you get, if you send all inputs in, that collection is called the range. In Swedish, what is called? Yeah, there is a name for it. Haven't you heard about this in Math 2C? So, yeah. So, I don't remember. So, Värdemängd or something like that. So, that is the range, and the other one is the domain. So, anyway, the collection of all possible inputs is called the domain of my function. And let us imagine that you have enough time. Of course, it is not always possible because you have infinitely many possibilities, but you can imagine that I send all inputs in and get all outputs, and put them in a collection, that collection is called the range. So that is why finding the range is not that easy, okay? Because then you need to have a good imagination what will happen if I put every input in, okay? So that's what the collection of inputs is called the domain. It means which numbers I can, which things I can send in. But because we are working with functions in mathematics, these are usually numbers, okay? And then what I get out, the collection of all outputs is called the range of that function. So for example, what is the domain of this function? F of x equals to x squared. When I ask this question, I mean, is there any limitations for the inputs that I can provide for this machine? Of course, in the set of real numbers, I do not have any limitations. I can choose any real number that I want to. So the domain of this function is simply the set of all R. Yes? And what is can, of course, I will not talk about the range that much, but let us try to understand things. Can you imagine what will be the range? You need to imagine in this way. Imagine that I send all possible real numbers into this machine. For example, if I send 1 to this machine, what do I get out? 1. If I send 2 to this machine, what do I get? 4. If I send square root of 2, what do I get? 2. So yes, it is clear. Now imagine that you have sent every possible input in, and then you get a lot of outputs there. What will be the collection of all outputs that you can see? Just imagine intuitively, yes.
The set of all the numbers.
The set of all real numbers. Is that right? Yes?
It will be equal or bigger than 0.
Yeah, not possible. There is no way that you can get a -5 here. Yes, do you agree? Is there any input that you can send in, it gives you -5 out? Is it possible? No, because it doesn't matter what you send in, because this machine squares that, it becomes a positive number. So there is no way for you to get a -5 out of this machine. Yes? Am I able to send -5 in? Yes. But even if I send -5 in, what do I get out? Positive 25. So as you said here, the range of the function f, so this is the set. Usually people write it like this, R, but not all of R, they put greater than or equal 0 on top. So this means the range of this function is the set of all non-negative real numbers. Can I get 0 as an output? When I send 0 in. Yes? So 0 is also in the range. Yes, there was a question here somewhere. Okay. Is that clear? Yes? So the notion of the domain, you should have a good grasp on it. The notion of the range is a little bit hard. You need to know what does it mean, but you really don't need to be worried about that much. Okay, so here, so can you see, if I want to imagine this as a machine, what is that machine? So let me call it G. I send X in. What do I get back? 1 over X. This is a very good visualization of a function. Instead of drawing lines and writing so much, mathematicians write G of X equals to 1 over X. But this means exactly the same thing. Okay? So I can call it inversing machine, for example. Whatever number you send in, it gives you the inverse of that number. So, but can you see that there is a limitation of the numbers that I can send in? I can send any number in except one possible number. And what that number is? 0. Because if I send 0 in, the function is supposed to write 1 over 0, and it gives you error. Yes? Because there's 1 over 0 is not defined. So if I ask you what is the domain of G, you can say R not equal to 0 or something like that. You can write it in words. The way that in Swedish books they write it is not correct. Okay, so they write x not equal to 0. This cannot be the domain. The domain in mathematics is a collection. Okay, this is a statement. But you don't need to worry. If you write x not equal to 0, it's acceptable. Okay? Okay, so now when I say the domain, this is when I say the domain, I am asking you find all possible, the collection of all possible inputs that I can send to my function. Okay. How should I answer this question now? Let me write the simplest function that we want to talk here today, and that is the tangent itself. Okay. So let me write number one. So I'm just writing the example here. Number one. Let me write, for example, f of x equals to tangent of x. So I want to find the domain of this function. So how should I find the domain of this function? It means if you want to go to a scratch paper, you have a function f, you send x in. What does this give you back? It gives you tangent x. Okay? But tangent x has also another name, which is sine x over cosine x. So what is there any limitation for the values of x that I can send in? The answer is yes, because some of these x's makes the denominator 0. And if the denominator becomes 0, division by 0 is not acceptable, so then I will be in trouble. So this means that if I want to find the domain of this function, I need to ask myself for which value or values of x I am in trouble. I am in trouble if this happens. Okay? So this is not the domain. This is exactly out of the domain. This is the one that makes trouble for me. Okay? Then I exclude them from the set of R. What is left for me is the domain. Okay? This is why in the book they sometimes don't ask you about the domain. They ask you for which values this function is not defined. Okay? So for which value this function is not defined, for those values for which cosine x is equal to 0. But then you have to solve it. You remember cosine x equals to 0 is one of the simplest trigonometric equations ever, yes? So how should I solve it? Cosine x is supposed to be 0 on the unit circle. When cosine is 0? 90 degrees and this one, yes? Either I can write 90 degrees plus 360 degrees and 270 plus 360 degrees, but you can use the trick, you know? Instead of going one full round, if I go half a round, I will cover both of them. Yes? So then this means that x is equal to, let me write it in radians. So pi over 2, not plus 2n pi, I just write plus n pi. And n belongs to z. Okay? So this is, I hope that you haven't forgotten, yes? We worked a lot in solving these equations. So this is not the domain. The question is asking you the domain. Sometimes they ask you for which values the function is not defined. That is the solution. Okay? But if they ask you about the domain is what? The domain of the function is x not equal to this. Yes, because if x is equal to this, I am in trouble. I don't want to be in trouble, so I have to avoid this. Yes. So this is the domain of the function. Yes.
You said we shouldn't use the inequality sign, right?
I told you, yeah, but this is the way that Swedish books write. Because
So-
technically speaking, x is not equal to this is a statement, is saying something. But domain technically is a collection. In mathematical terms, we will study this in set theory in Math 5. That is a set. So if I want to write it properly, I have to write this df is equal to the curly brackets, means the collection, of all real numbers. And this vertical line means such that x is not equal to pi over 2 plus n pi, where n is an integer. Okay? But of course, this is the grammar, okay? But the concept is exactly what we did. If you want to write it properly, you have to write it in that way. But don't worry, just write it, that's enough. Okay? But that means this. Okay? Okay, any questions? Okay, I haven't talked about the graph because I want you to first understand this, then we'll go to the graph. Okay, so let me add one more question here. I can choose it from your book. Number 2. This is the question. Y equals to, they have written y instead of f of x or whatever, minus 2 tangent 45 degrees minus x. This is one part of question 2336. Okay, there is more to it. I will discuss about that later. Okay, so we want to find the definition, the domain of this function. Okay, again, how you need to think about the problem. You send x in, this machine operates something on your input. What do I mean by something? I mean whatever you send in, the machine subtracts it from 45 degrees, it becomes an angle, takes a tangent of that angle, whatever that is, it multiplies it by minus 2 and gives it back to you. That's the operation that the function does, okay? So and now I want to find the domain. You already know what is a tangent. Tangent can always be written as sine over cosine. So it becomes sine of 45 degrees minus x over cosine of 45 degrees minus x. Tangent of any angle is the sine of the same angle divided by the cosine of the angle. Okay, do I have problems? Yes, because if this denominator becomes 0, I am in trouble. So I need to ask myself for which values I am in trouble. For which values of x I am in trouble. I am in trouble translates itself to what? This becomes 0. Yes, is that right? I'm asking for which values I am in trouble. Trouble means the denominator vanishes. Okay, but this is the same thing, a story, yes? So the cosine of an angle is 0. Do you remember, if you want, you can use these formulas, but I don't want to use them because this would be very lengthy. Do you remember, if you have the cosine of box equals to k, then the box here, this shows me that I have to solve it in degree mode. So this means that it becomes plus or minus cosine inverse of k, yes, plus n times 360 degrees. Yes? But of course, k in this case is 0. Cosine inverse of 0 is 90 degrees. So it becomes plus or minus 90 degrees plus n times 360 degrees. Yes? This is correct. You can write it in that way. But let me remind you again. Sometimes two formulas can be combined into one single formula. Yes? What does it mean? It means that I have 90 degrees, which is here, plus any full rounds, and minus 90 plus any full rounds. So if you want to insist to write full rounds, you have to keep both of them. But there is a shortcut to it, yes? Instead of going full rounds every time, I can go half a round, yes? So these two formulas can be combined into one formula as 90 degrees. The price that you have to pay for taking this off is to make this 180 degrees. Yes, is that right? So this is just a review, if you have forgotten. Okay, so what I'm doing is this. So I would write what? I would write 45 degrees minus x, which plays the role of the box here, is equal to 90 degrees plus n times 180 degrees, where n is an integer. Yes? And then, of course, you are looking for x, so you have to solve this. So what do? I move 45 to the right. It becomes 90 minus 45, which is 45 again, and plus n times 180 degrees. Yes? But I am looking for x, so I have to multiply by minus sign. Okay, you can keep it like this, but usually the math books prefer to make it positive if possible. Do you object if I make it positive right away? Of course, when I can, this minus n is also an integer if n is an integer. I can call it a new n, but let me choose a different letter. So let me choose m. So this becomes m times 180. But if you stop here, that's also okay. But be careful. This problem is asking you about the domain. This is not the domain. This is exactly the opposite of the domain. This is the points that makes trouble, yes? So I have to exclude them. So the domain of the function, whatever it is, let me just write d. Don't write equality, because if you want to write equality, you have to write it in that way. So put semicolons and then exclude them. Yes? Is that clear? So what does it mean? It means that when you have, so it means that these numbers should be excluded. And then we draw the graph, you will see what is happening if I want to exclude these points. How many points are excluded? Infinitely many, one for each choice of m, yes? For example, if I choose 0, it means minus 45 is excluded. If I choose m equals to 1, 180 minus 45 is 135. It means 135 is also excluded. All possible values coming out from this formula are all excluded. Yes? Okay, so that these two examples are good. Let us now go to the draw the graph of the function. Not draw, I just want to sketch the graph and give you a feeling how it looks like. Okay. Before doing that, I want to follow exactly your book. So the book is introducing a new axis, a new axis as the tangent axis. So here, if you remember in the beginning of this lesson, we had the unit circle, and this is the x-coordinate. This is the x-axis, and that's the y-axis. I can say the x-axis is the cosine axis, because you remember that the cosine is related to the x-coordinate, and I can say that the y-axis is the sine axis, because sine is related to the y-coordinate. But we didn't talk about tangent axis. Now the book is introducing you a new axis, okay, that is here. Okay, so they draw a tangent line here, yes, and then take this point A. Do you remember this point A was the origin of the unit circle? From this direction is positive, this direction is negative. But then they draw another axis which is tangent to the unit circle at this point. And then they call this black axis the tangent axis. Okay. So, and this is the origin. So this means that whatever number is below A is considered to be negative. Whatever number whatever point you see above that, they consider with a positive value for the axis. Okay, but how this is helpful? This is good actually, it's not that bad. So here, if I give you an angle theta, before having this black axis, if I ask you about tangent of theta, what should you do? Let us say that for the time being, let us go back to this very old lesson. Don't consider the black axis. I give you this angle, and I give you, for example, a precise ruler, and I ask you to find tangent of theta. What do you measure? You say to yourself that tangent theta is the y-coordinate of this point divided by the x-coordinate of that point. For example, you take your ruler, measure this length, it becomes the x value. You take your ruler, measure this length, it becomes this value, and you divide. Okay? But now, my claim is that if you have this black axis, you can do it simpler. instead of using the ruler measuring two things, what you can do, you can continue this line, whatever it is, so that it intersects the black axis. My claim is that this length is tangent of theta. Okay, so this is easier to find tangents. So if I give you an angle and I ask you the tangent, you draw the tangent axis and then continue the side of the angle so that it intersects the tangent axis, and then you measure the length from the intersection point to the origin. But if it is above, the value is positive. If it is below, the value is negative. We come to that, okay? But that is very, so if this is, I just claim this, but I want to prove it first for you that why this is working, and then we can explore the consequences. Why do you think it should be tangent? Is the claim clear? So let me take this off. Write it L. I want you to tell me why L is equal to tangent theta. Yes?
I think if you divide the opposite like A,
Mhm.
then you have opposite is Y, and the A is X. So you should get
The opposite is, so y is this length, and x is this length. Yes?
couldn't you use Pythagoras? Not because it's 90 degrees.
No, it is 90 degrees. So this angle is 90. This angle is also 90. Yes? Okay. But Pythagoras gives you, okay, what do you want to calculate? I mean, what you said is more or less correct, but I don't know why did you stop. So, tangent theta in this right angle triangle can be written as what? So there are two ways to consider this. Either you can use similarity of triangles, yes? So for example, do you see that this smaller right angle triangle and this bigger right angle triangle are similar? Why? Because they share one angle, and one angle is 90, one angle is 90. So these two triangles are similar because two angles of one of them is equal to two angles of the other one. If this happens, the triangles are similar. This is the theorem in Math 2C. Okay? But if they are similar, what does it mean? It means the ratio of x, let me call this O, the ratio of x to OA is equal to the ratio of y to L. Yes? That's the meaning. But what is OA? Yes? 1. OA is 1. No, OA is 1. This is cosine. OA is the whole radius, which is the radius of the unit circle, and that is 1. So this OA is 1, so it is just x, is equal to y over L. This means Lx is over y, is equal to y when I multiply by L. I am looking for L, so L becomes y over x. But what is y over x? Y over x is the tangent. Yes? So this is tangent. So that's the proof, okay? But if you don't like the proof, at least you need to know the information. So from now on, you have two ways to calculate tangent. Without the tangent axis, as we learned before, or with the tangent axis. If I want to use it with the tangent axis, I just continue the length of the angle to find the intersection point and find the length from the intersection point to the origin. And if it is above, it is positive. If it is below, it's negative. Yes, for example, you can probably immediately imagine what happens if it is 45 degrees. Of course, you already know what is the tangent of 45 degrees, but it doesn't hurt if we do it once more using the tangent axis. So, if this is 45 degrees, and I want to know the tangent of 45, one way is to continue this length and find the intersection. Can you see what this length will be? Of course, my figure is awful, but you can use the symmetry in your brain. So what do you think this length will be? It will be 1. Do you agree? Because if it is 45 degrees, This also will be 45 degrees. So this triangle is not only right angle triangle, but also isosceles. So this means that this length and that length should be equal. So this length is 1, so that length should also be 1. Can you see, for example, the tangent of the angles in the first quadrant are all positive? Yes, because it doesn't matter where I have this angle in the first quadrant. For example, even if I have this angle, when I continue this, the intersection point will be up there, but it's still positive. Yes? But can you see, for example, if this angle is in the second quadrant, what is the tangent now? If I continue this arm from this direction, there is no hope to get my intersection. Yes? So I have to continue it in that way to get the intersection. Yes? And if I continue this in that way to get the intersection, this becomes my length, but it will be in the negative part. So it is clear that if the angle is in the second quadrant, the tangent should be negative. So I am rediscovering what we learned before, but using this new concept. Is that clear? For example, what was tangent of 90? 90 degrees? It was undefined. Why? Because it was y divided by x. When I am standing here, x coordinate is 0. From this picture, do you also see that it is undefined? Why? Because if this angle is 90, this is the angle 90. This is the second leg of the 90 degrees. So if I continue it, I will never get the intersection point, yes? Because this leg and that are parallel. If I continue them in every direction, in both directions, I will never get the intersection point. So this means tangent is not defined in this language, yes? So for example, what is tangent of 180? 180 is this one. So the second leg is this. Then you have to continue this leg to intersect with the tangent axis. There is no hope if you extend it in that direction. So you extend it in the opposite direction. But where will be the intersection point? The point A itself. And then the distance from the point A to A is 0. A tangent of 180 also is 0. Yes? Is that clear? So there's an alternative. Why this is good? Because I can ask you some question now to see. Let me draw a cleaner picture here. So we have this unit circle, and then we have this tangent axis. Okay. So let me write 10. Okay. What do you think is the range of the tangent function? Even though I told you that you really don't need to be worried about the range that much, but now I see in the book they are asking some questions about the range. So what do I mean by that? So let us say that this is the tangent function. I send some values in, and it gives me the tangent of, so I send x in, it gives me, so let me call it theta. It gives me tangent theta out, okay? There are some limitations for the inputs, and we solved this before, so this is still on the board. So I am not allowed to send these numbers in, okay? But except these numbers, I am allowed to send whatever I like to, okay? But the point here is that, can you imagine what will be the range of my function? Okay, this is why this picture is very useful, because if you want to solve it, it is not that easy. But can you visualize the range of the tangent function using this structure that I told you? Yes, so your claim is that it covers all the real numbers. So this is important. You are not allowed to send all real numbers in. So you have to have some gaps, you have to take some of them out. But still, it will not affect the range. The range will cover all real numbers. Let us try to understand, try to explain this to you. My claim is that the range of tangent function is the set of all real numbers. I will explain it for you, but have it in the back of your head in case that they ask questions. Remember that the range of the tangent function is the set of all real numbers. If I want to claim this, if I want to explain this that is true, I have to show you any number will be eventually covered by tangent function, yes? It means, what does it mean? Do you think that this point, I am choosing random points on this line, okay? It covers all real lines. Do you think this point will be covered at some point? Do you agree with that? Which angle will cover this point? Yes? No, you don't need the angle. I don't know either. But I mean, I can construct it geometrically. Which angle covers this? The angle, so that when I continue its leg, it will intersect the tangent here. If I ask you which angle, you will tell me this angle. Yes? Is this point covered? Yes. By which angle? By this angle. Is this point covered? Yes. By which angle? By a little bit smaller angle. But it is covered. Is this point covered? Yes. By something in the middle. Is this point covered? Yes. By which angle? By, for example, this angle. So you see that every point here will eventually covered. Don't think about minus infinity and plus infinity, because minus infinity and plus infinity are not numbers. Okay, they are not real numbers. Okay, but any point that you see here will be covered by some angle, and that is also interesting. The angle is either in the first quadrant or in the fourth quadrant. So this is the range of the function tangent is the set of all real numbers, and every real number using the tangent function can be covered with an angle from 0 to 90 or from 0 to minus 90. If you want to cover the positive part of this axis, you only need the first quadrant. If you want to cover the negative part of the axis, you only need the fourth quadrant. You also, of course, you can also cover with some angles there, but you really even don't need them. That is enough to cover the whole range. Okay? So the range of the tangent is R. Any questions here? Okay, but now if I want to have a good grasp of the tangent function, let us draw the graph, sketching the graph to understand what is going on. First of all, this function is a periodic function. Okay, so f of x equals to tangent of x. F of x is a periodic function. The period is what? 180 degrees. So what does it mean? It means that I don't need to bother about drawing the graph in the full range of the domain. I just need to draw it in one period, as before. Copy and paste it over and over again to find the full range graph. Yes? And because the period is 180 degrees, I draw it in one period. But it is common, take this interval to be from minus 90 to 90. Yes? This is the standard way of drawing it. And you can see it why here. It is coming from here, because from minus 90 to 90, you cover everything. Okay? What is the length from minus 90 to 90 is 180. You might ask, can I draw it from 0 to 180? Yes. Can I draw it from 180 to 360? Yes. Okay, but the standard one is from minus 90 to 90. Okay? So if you want to draw that, what do you do? The first thing that you need to to make it clear, even though the book is not making it that clear, are the points that I have to exclude. Okay? So you already know tangent of 90 is not defined. Tangent of minus 90 is also not defined. Okay? Yes, we learned it from here and also from before. So let us say that this is 90. And then this is minus 90. Okay? So you are not allowed to be somewhere on this line. Yes? You are not allowed to be somewhere on this line. The graph will not go through these lines. So you can be here, you can be in between, but you are not allowed to be on this line nor on that line. Because if you are on this line, it means x is 90, but tangent of 90 is not defined. Okay? So if you stand at this point, look upwards and downwards, you will not see the graph. There is no point of the graph up there or down there because it's not defined. The same here. Okay, so I will draw the graph of my tangent within this interval. And after that is finished, because the period is 180, I take it and copy and paste it from the right over and over again, and the same for the left. And that whole thing will be the graph of one single function, and that is the tangent function, okay? And then, of course, you can, because if you want to draw the graph more or less carefully, you need to know the notion of derivative, which will be the topic of the next chapter. So I just do simple calculations. So I will give x and y. So I will say 0 for x. The tangent of 0 is still 0. So this means this is my point. Okay, so let me give some numbers that I already have in my memory. So I am supposed to go from minus 90, which is not defined, here not defined, here not defined, but I can be in between. Okay, so I have it in my memory. If I put 45 in tangent, it becomes 1. If I put minus 45, it becomes minus 1. So if I find these points, so this is 45, let us say this is 1. So this is 1 point, 45 degrees. And then minus 45 is here, and then I have minus 1 here. Okay, so the graph should go from here to here and to here. Okay. There are many ways that I can draw the graph, okay? But later we will see that the graph shouldn't be like this. The reason we will see later. If the graph is supposed to be like this, okay, it means that the derivative of the tangent function at the origin should be 0. Okay, but we haven't talked about the derivative, so I don't want to distract you from these things. Okay, trust me for the time being on that the graph will go something like this, okay, and something like that. Okay. But what do you think will happen if I make my angle bigger and bigger to 90? If I get closer to 90, what happens? You see, so let me draw a little bit better picture. So this is the tangent axis. So if this is the angle, tangent is this much. If I increase the angle and make it closer to 90, what do you think is happening? Okay, and if I increase it more, what do you think will happen? Yes, say something.
It becomes larger.
Yeah, it becomes larger and larger. And when it becomes very, very close to 90 degrees, because these two lines become approximately parallel, the intersection point will be very, very high. So it means that when I get closer and closer to 90, the point, at 90 I'm not allowed to stand, but if I am very close to 90, what do you expect for the y value? The y value should be huge. Yes? So let us imagine that the y value is huge here. And if I go to minus 90, what will happen? The value still becomes huge, but in the negative part. Yes? So this means that when I get closer to minus 90, it becomes huge and negative. So this is more or less the sketch of the function tangent of x in the interval from minus 90 to 90. But this is not the whole story. If I want to draw the graph of the full tangent, I have to take this picture, repeat it again, for example. This is 90, and then I have to repeat it, dot, 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 and then I have to draw something like this again, and again from this direction, and again from that direction. So you see that you have infinitely many branches, but how many functions you have? You have only one function. So that's one function generating infinitely many branches. Okay? And what is happening here? These lines that you see, later we will study them. They are called vertical asymptotes of the function. Forget about the name if you don't like it right now. But these are the points at which the function is not defined. So they are excluded by these dotted lines. I don't know why the book doesn't draw these dotted lines. But usually The reason the book doesn't draw that, because might be you will be confused that these dotted lines are also included in the graph. No, the graph are the solid branches. These dotted lines are for guiding you to draw it a little bit better. Okay? But these are not part of the graph. So from that perspective, book is right. If you want to imagine the graph of this function, you have to exclude the dotted lines from your brain. Okay? Any questions? Is that understandable? Okay. So let us see what we have. GeoGebra as well. By the way, whatever I said, do you remember about the transformations? For example, if you change x to minus x, y to minus y, if you add something to x, all these things that I told you before are also valid here, because I told you for every function, including sine, cosine, and tangent as well. Okay. So let us go to GeoGebra here. So and then try to draw the graph of the function tangent of x. But of course, you know that GeoGebra by default draw it in the radian mode. So if I want to change it to the degree mode, what we are supposed to do you remember? So we go here and then choose this distance, for example, to be pi over 2 is good for the tangent. Yeah, it seems good. Yes. Let me see. So I would draw the graph of the tangent y equals to tangent of x. Yes, so let me, yeah. So this is the graph of the tangent, and you see that GeoGebra also does not include the dotted lines, okay? But you can feel the dotted line, yes? So you see that I have infinitely many branches. So the graph of the tangent function is whatever you see in green color. And of course, more than that. If you go to the right, infinitely many, or to the left, you will see the same thing. So is that clear? Okay. So something like this you need to know. For example, if I give you a function like this without saying you that this is the graph of a function, then if I ask you what the domain is, so do you see which points are not included? Yes, I don't know how to draw it. For example, you see that this point is not included. Why? Because if you go higher and higher, of course, the branch of the function is getting closer and closer to this line, but yes, this doesn't intersect. So it means that above pi over 2, you don't see any green dots. Below the pi over 2, you also don't see any green dots, as if you look above directly or below, okay? So this means pi over 2 is excluded. And this means that pi over 2 is not in the domain, okay? But how many points are being excluded? It is simple to see pi over 2 is excluded, 3 pi over 2 is excluded, and so forth. And from the left, minus pi over 2 is excluded, minus 3 pi over 2 is also excluded. Yes? Is that right? Okay. And then what is the period? If you want to understand the period of a tangent function, so you can see that from here, for example, to here is one length that the function repeats itself. Yes? It doesn't matter. You can say that this is from here to here. Yes? Yeah. Because the length of the period is pi, or 180 degrees. Okay, any questions? Yeah. So I think, yeah, we are more or less done. Of course, when I say more or less, it means that it is up to you how many exercises you want to solve, but that is a lengthy and a little bit technical chapter. The next chapter, at least you have a feeling about it, and that is the notion of derivative. That is harder. They can design more creative questions in that part, but at least more or less you have it from Math 3C. Okay? Any questions? Okay, so let me stop here so that we can decide about the exam and things like that.